So, let me start by introducing you to Sid. Sid is a beagle from Austin, Texas, and he has this thing, I don't know if it's a fetish or just something he does, where he likes to hold food in his mouth. He doesn't eat it, he just holds it there, just sitting there wagging his tail and salivating a lot. Actually, if you notice, just before the video loops, right at the corner of his mouth, there's a bit of drool coming out. Like, right there, did you see it? It's amazing. So, essentially, right there, Sid is the most excited creature in the whole world, I think. Which is why I picked this GIF to open my talk, because I'm really excited about this thing in JavaScript in ES6 called generators. And Sid definitely mirrors my excitement here. Let's get back to Sid later. So I would like to show you generators, but to get there, I need to show you another new thing in ES6, which is called iterators. And essentially, so you have arrays in JavaScript, right? And the way you would iterate over them is you would probably use something like a for loop. Or if you're functional programming, you might go like a fold or whatever. But a new thing in ES6 is sort of a standardized way of iterating over a collection. And there is now a method on arrays, for instance, called values, which will get you an iterator object for iterating over the array. And essentially what that is, if I store it somewhere, it has a method called next on it, which you can call, and it will give you an object containing the first value of the array. That's Applejack. And a property called done, which will be a Boolean, telling you whether or not you're done iterating. And you can keep calling that. You get Fluttershy, you get Pinkie Pie, you get Rainbow Dash, you get Rarity, you get Twilight Sparkle, and you are done. So that was a lot of ponies. What's the REPL? It's something I write. No big deal. So anything that has iterators or is iterable, there is a new for construct. Let I of ponies that you can use to get a for loop of everything that is iterable. So I can go like console.log I, which should get me a list of all 6 ponies. It's very nice. So that's the basics of what an iterator is, of arrays at least. Oh, what did I do? Stop, go back, there we are. So, computers, you know how it is. Okay, so, I didn't test that. Just gonna use the other mode. Right, sorry about that. So we've iterated over arrays, but the iterator is really just an arbitrary interface. It just essentially is something that can give you an iterator object with the next method. So you can implement iterables and iterators any way you like, really. You can, I made a little custom one here. Essentially a very simple state machine, which starts at the number 0, and the first time you next through it, it increments to 1, it gets you Pinkie Pie, then it increments to 2, it gets you Rainbow Dash, and then I can be asked to put in more ponies, but you get the idea. So you'll notice there is a symbol.iterator method. This is another new feature in ES6 called symbols, which are essentially exactly like symbols in Lisp. And symbols, in addition to strings and numbers, can be keys on JavaScript objects. And they've decided, for whatever reason, that symbol.iterator should be the method name for getting you an iterator out of something that is iterable. So an iterable is any object that has a symbol.iterator method. So we can go on our custom iterable, symbol.iterator. And we call that function, we should get an iterator. And I call i.next, c is now 0, It's now 1, it says Pinkie Pie. It's now 2, it says Remo Dash. And we're done. So yay, we can write custom iterators. Some of them could be more useful than this. Like, say, here's my infinity iterator. That is essentially an iterator that will count forever. So if we go infinity symbol.iterator, and we go next, and it goes on like that forever. Of course, you can also do a for loop over this. What do you think? Do I press return? That's actually going to crash my browser. And since this is a Chromebook, that means I crash the entire operating system. So let's not. So this is where I should probably introduce it to a little amendment I made to JavaScript in my repo. Essentially, if I start a line with an ampersand, and I give it an iterable, it will resolve it for me, but only up to 10 values. So that's the safe version of this. But essentially what I got here is I've got a lazy sequence. And that, if you're doing functional programming, that could be fairly useful. Like, say, if you're doing closure has 3 main selling points, right? It's got persistent data structures, it's got lazy sequences, and it's got lots of parentheses. So we're at 1 of 3 in JavaScript now. Actually, we could go like, I don't know. You can certainly add the parentheses in if you like as well. And so we're nearly at closure at this point. More usefully, though, we could perhaps build a little library of functions that work in iterators. They will have a take function. Because right now, if we try and get all of infinity, that's not going to work out so well. So suppose we have a take function instead. So we can go like take 5 out of infinity. That gets us 0 to 4. That's cool. It's a bit boilerplatey, but it works. We could go further. We could have a map function. We could go like map I to I plus 5 over take 5 out of infinity. And that gets us essentially 5 numbers starting with 5 and counting upwards. We could even just do this over infinity, and it will take 10 numbers out of that. And it doesn't compute the values for the rest of them, of course, because we are having lazy sequences here. They're composable, you'll notice. I fed the result of take, which is an iterator, into map, and that goes as an iterator out with the function applied. So it works as expected. That's quite useful. Now, the problem, though, is these functions are really ugly. There's a lot of boilerplate going on. You've got a function that returns an object that has a symbol as iterator method, which is a function that returns an object, and so on. And it's just, it's like being back in Java, isn't it? So, pause for a second just to rest your mind with Sid. That's Sid with bacon. Still looking quite pleased. But let's move on to generators. So these iterators are amazingly useful because they give you things like lazy sequences, but it kind of sucks to write them in this way. This is where generators come in. Essentially, they're a special sort of function that helps you write iterators, like the special sort, that's a function with a star on it, and it can take arguments as usual. And so let's re-implement infinity using iterators. Sort of the same thing, except without the boilerplate. I start out with number 0, and I go into an infinite loop, while true, and I go yield, C++. That means C, and then increment C by 1. It's not the language. That would suck even more. So what's going on here is essentially the yield statement is sort of like a return statement, except the function doesn't stop. It just pauses at this point. It takes the value that you pass into yield, which is going to be C, and it returns that as a result of the iterator when you call next. So what you get out, it's better if I show you. If I call this function, what I get out is not my browser going into an infinite loop because the while true. It's an iterator. And currently, this function hasn't actually started running yet. It's sort of paused right at the start of it. And the first time I call it, it starts running. It assigns 0 to the C, and it hits the loop one time through. It will return 0 and increment C. And at this point, it's paused at the yield statement. The yield statement has told us to put the 0 back out. And now this function is paused. And if I call it again, it will continue running through the infinite loop. And it goes on forever. So that was the infinity iterator function without the boilerplate, implemented as a generator. And oh, that was too far. Actually, yeah, let's not watch me re-implement these. So these are the take and map functions implemented as generator functions. They work the same way, except you'll notice a distinct lack of boilerplate. They're a lot easier to work with. They work, of course, in the same way. You can go take 5 out of infinity, and you get the first 5 numbers. We can get map I plus 5 to take 5 out of infinity. Are my parentheses balanced? No, they are. And it has the same effect, except now we're using generators instead. Just a quick look at the implementation. Essentially, whenever you have, so we're taking an iterator in, and we have a while loop that keeps going until the iterator tells us it's done, which in the case of infinity will be never, but in the case of the take, it's whatever many values we put in. And that's the same thing, except using generators. Now, so generators are a nice way of helping us write iterators with a bit of syntactic sugar. But we can go further, because we can have iterators where instead of just things coming out of them, which is rather boring, we can also put things in. Like, I've implemented this 5up function, which essentially will keep going forever, and it will keep returning whatever you put into it, plus 5. You'll notice at this point, we're actually storing the result of the yield as if that is an expression. And indeed, let me just show you how that works. So when we call it, we get an iterator as usual. And the first time we call it, there's no point in putting a value in, because we haven't started running the function yet. So we haven't gotten to the part where we actually will assign this to something. So the first thing that happens is we assign C to 0, and we yield the 0. So 0 comes out. And now we can start putting other things in, like next 5. We get a 10 back, because that's 5 plus 5. Fancy that. We can go like 100, it's 105. Minus 50 is minus 45. You're starting to get the idea. Not a number is null. That's interesting. Of course, string 5 is 55, because why not? JavaScript. And so on. The idea is these are actually two-way. Generators aren't just syntactic sugar for iterators. They're actually real coroutines. So I'm sure that, having seen this, you're all pondering more useful applications of this. I'm sure that you've all thought the same thought that I had the first time I saw this. What if we put in promises? Pause for Sid. This is Sid with pizza. I think that's his most famous performance. Chewing a bit on it there, cheating. Okay. What if we put in promises? So promises in ES6, promises are now standard in ES6, and essentially promises are an attempt at getting us out of callback hell. If you've seen any sort of node code, you know that starts to look a bit nasty. So promises are sort of a formalized way of doing asynchronous operations. And so let me so I've got this unit function here, which creates a promise that's already resolved. So if I got unit of 5, I get a promise. And my ampersand trick also extends to promises. It will resolve the promise and print the result value. So this should be 5, yeah. And promises have a method called then, which is essentially for registering a callback for when the promise has resolved. So I can go something like this to log 5 when we have a value. And suppose we have something like a generator function which yields promises, like just a couple of common words in strings, like OMG, WTF, PBQ, like normal words. So what if I iterate over this? So the first next, of course, is just a primate. We should get a promise out. You'll notice it's fulfilled to OMG, so it would expect us to resolve it with OMG, calling the value that came out of the promise, or passing the value that came out of the promise to the iterator. So it will then hit the first console.log, log OMG, and give us the next promise out, WTF. It's a nasty word, so let's go lol instead. And it will log lol. Our promises function didn't know that we actually passed something else back. That's irrelevant at this point. We can go completely crazy. We can go like negative infinity. And it will log negative infinity. At this point, note it's done. It returns done true because we ran out of promises. So we could sort of not do this manually. We could make a function called run, which simply takes one of these iterators and does this whole process for us, waiting for a promise to resolve, then continuing the iterator when it does. So I'm going to implement that. First, we prime the iterator. Notice what I'm doing here. I'm going to be doing a bit of recursion here. So this is another new feature in ES6 where I give the second argument a default value. So if you call it without a second argument, it will be initialized to null. And because the first time we call the iterator, it's irrelevant what we pass in. It's not going to actually use it for anything. That'll work out. And the second time we call it, we just recurse on the val, and values will be inserted. So if we are not done yet, then we take the promise that's next to the value, and we call then on it to register a callback. And that's a function that takes the result and calls run on the iterator and the next result. Now, if we go run promises, it does what we expect. But notice what's happened here. These are actually, I mean, they're pre-resolved, but they are asynchronous functions. We are getting there through callbacks. But this code isn't callback held. This code isn't even promise held. This looks just like synchronous code, like blocking I/O from the good old days of C and Java, except the use statement tells us we have to wait for this thing to finish. So that's pretty cool. We can go further. So there's a new thing in not ES6, but in browsers in general, called the Fetch API. And that replaces the wonderfully named XML HTTP request, which is how you would make HTTP requests in the bad old days. What it does, let me show you, is it just takes a URL and it will return us a promise, which will resolve to the contents of that URL. Actually, what it resolves to is a response object, which should have a method called text, which will return another promise with the actual contents as a text string. So this is the first paragraph of the famous literary work Fallout Equestria, which is a mashup of a fan fiction mashup of the Fallout franchise and My Little Pony, because why not? It's actually a wonderful novel. You should absolutely read it. It kept me captivated for a very long time. Might just be me, I don't know. So anyway, we can actually try our run function on this fetch API thing, because we are able to resolve promises now. So let's see what happens. Whoa. Oh my God, caps. So first we get the response object by yielding on a regular fetch. Well, that's a text. And then we need to get the text out of the response. So that's yield response.text. And then finally, we can say, look at that. So we now have what hopefully will be Fallout, a bit of legitimate asynchronous I/O, but it's written in a style that looks completely synchronous. No callback head in sight. And it works. It's quite neat, I think. So one problem, though, we're not able to deal with return values from this. We'd actually have to do a console.log at the end, which is sort of not ideal. So I wonder if we could change the run function a bit, so we're able to generalize this. So essentially, we want to return a value when we are done iterating. So if we put a return statement in the generator, we should get a value out. So what run should actually do is it should return a promise that's going to resolve to this eventual return value. So I'm just going to add another default argument, which is going to be a deferred promise, and going to expand the if statement a bit. Oh, and we should also, of course, keep passing that on when we are recursing. And so when we are not done, we keep feeding values back into the iterator. When we are done, then there is a property on the generator function where if you actually return something at the end of it, you don't just get the done true object, you get the done true object with a value. And we're going to take the value out, and we're going to resolve the promise with that value next to the value. And at the end, of course, we have to return the promise that we are eventually going to resolve. So this should allow us to write a completely generic function for fetching a piece of text. So a generator function which takes an argument with the URL that we want to fetch. And let's just dive straight in and write some nasty looking Haskell code here. Instead of actually just storing the intermediate values, I'm just going to use them directly. Just a lot of yield statements. That's about the same thing, except without storing the response in the text anywhere. Point freestyle, right? So let's see if this thing works. I should now be able to run fetch text with an arbitrary value. Data/text. And it should now actually give us a promise that is going to resolve directly to the contents of that file. And we're going, the ampersand, of course, prints the value of that promise. And oh, that's private. I'm sorry. That's not the fallout text. It's actually, I was writing a novel. I don't think it's, I don't know. No, that's fallout. Much better. So at least now I've proved that I can pass arbitrary URLs and get the contents of that URL out. It's not hard-coded to fallout anymore. So we are now doing asynchronous I/O fairly neatly. We are even able to write generic functions that we can compose using this technique. It's pretty cool. It's not restricted to just doing like I/O with promises, though. Suppose we have this function here called things, which essentially, I have an object called ponies, which contain two ponies, pi and dash, keyed on pi and dash. So this function should return the fact that Rainbow Dash is friends with Pinkie Pie. Run things. So that's Rainbow Dash is friends with Pinkie Pie. Now, suppose that instead of Pinkie Pie, we are interested in Twilight Sparkle, who is also, coincidentally, Rainbow Dash's friend. Of course, Twilight Sparkle is not in the object. So what does JavaScript do? Of course, it should catch this at compile time, right? It's an obvious type error. Yeah. So at least we should get a runtime error. Because obviously, the JavaScript runtime is able to detect that the key twi is not in the object. Actually, Rainbow Dash is friends with undefined. The joys of JavaScript. What I'd actually like to do is I'd like to handle this problem. If not more gracefully, then at least I'd like to handle it. So I'm going to introduce something that looks like a promise. It'll have a then method, but behaves slightly differently. I'm going to call it maybe. It takes a value, and it returns something vaguely shaped like a promise. It has a then method, which of course takes a callback function. And now, what I want to do, if this value is null or undefined, then I should like to do nothing. But if it is something, I should like to just return the value directly. So if it's not equal to null, in JavaScript parlance, the triple equals, which JavaScript tells you to always use, will match this with null. The double equals in this case, which you should never use in any other case, will match it to null or undefined, which is what I want. So if it is not null or undefined, I want to call the function with a value that is stored inside the maybe, inside this closure. And if it is null, I just want to not call the function and just go null as a return value. So essentially, processing will stop at this point. The callback will never be called. It's just going to vanish out in the void and eventually, hopefully, get garbage collected. Well, yeah, semicolon. It was a reflex. I said Douglas Crockford, and I automatically added the semicolon. I thought I'd forgotten. So that's not what I wanted to show you. So maybe of 5. If I resolve it as 5. If I chain that with a maybe of 6, it should resolve to 6. Now, if I change the 5 to a null, it should get us a null and no final result. If I change it to string null, I'm not sure what will happen in JavaScript. This is such a wonderful language. Is that actually a null value? Nah. I get the 6th out, so evidently string null is surprisingly not null. So that's how the maybe works. I'd also like to add a prop function, which takes advantage of this. It will be a function that takes a key and an object, and it will return us a maybe of the contents of that key. Now I can rewrite the things function to, instead of just getting ponies dash out, I should like to yield on the prop call with dash on ponies, and do the same thing here, except not dash, but pi, and then go return dash's friends with pi. So now if I run it, it says rainbow dash's friends with pinkie pie, so in the correct case it still works. Now if I go to y, I should be getting nothing instead of getting the unpredictable error. So, I mean, this isn't a great way of handling it. What I'd actually like is to get an error. And a promise can return an error, and I could extend the run function to deal with that, but I'm not going to. Leave that as an exercise for you if you want to do it. But at least I'm not getting into a strange state. Instead of that, I'm just doing nothing. Nothing is happening. So I've shown you that I can use the run function with things that aren't just I/O operations. It's remarkably flexible what you can do with a thing, but maybe it's a simple example. So let's summarize. This is what an async operation looks like in JavaScript. It's just something which has a then method, which will take a callback function, which will eventually receive a value of type A. This is TypeScript notation, incidentally. This is for an async operation of type A. The callback function will receive a value of type A, and it should return a promise of type B. The then function will also immediately return a promise that will eventually resolve to the type B that you return from the callback function. We can add the unit function that I showed you earlier to get straight into a promise value that has a resolved value of type A. And now we got the shape of the promise. So let's review. We chain operations using then. This is straight promises. We can make the then chains go away using yield, combining it with our run function. And this is where it gets a little more interesting than just promises, because this allows us to forget that we are async, just putting the yield keyword in what way you need to actually wait for a value. And you write code straight up synchronous looking, imperative looking, blocking looking, what have you. And it is actually async. It works very neatly in JavaScript. That was a bit of a revelation to me that you can do this. And as I showed you with the maybe, we can do this with anything that has a then method. It doesn't need to be like a specific async fetch operation or anything like that. We can sort of change the semantics a little bit of it, using things like the maybe. So imagine a world without callbacks. This is Node. Imagine, at least, if Node's API functions return promises. So this is how you would now write a function that reads two files, A text and B text, takes the contents of these files, concatenates them together, and writes them out in a file called base.txt. It will look a lot nastier in regular callback style Node. Now I can do this instead. That is quite a brave new world, isn't it? Actually, it's just like in Haskell. This is the exact same thing in Haskell. Read a file A text and a file B text, and you concatenate them and get both text out. And you have sort of the same syntax. It's this do thing, which is sort of like our run function coupled with a generator. And the thing with Haskell is it's all callbacks. Because Haskell has this special property that no side effects are allowed. So a function is not allowed to cause a side effect. The only thing it's allowed to do is return a value based on its inputs. Which means that all side effects must be async. Essentially, when you want to do an I/O operation in Haskell, you will return a value that will arrange with a runtime to eventually produce a result and call a callback that you've passed to it to let you process the result of the operation. It has to be like this in Haskell. This is something that Haskell has been doing for almost 25 years now. It's not new and unique to Node. They were actually there 25 years ago. They hadn't figured out this do notation bit yet. This is Node callback handle. Actually, Haskell's callback handle was a lot nastier. Callback handle was neat compared to what Haskell used to do before they figured out how to do I/O properly. And there was one man in particular who proposed a solution for this. I've actually photoshopped his head onto this painting from Moby Dick. This is Philip Wadler. Hunting the great white whale, hunting the solution to async I/O in Haskell. And the solution that he came up with, of course, was monads. And I know what you're thinking right now. Oh my God, she's going to do a monad tutorial, isn't she? Thing is, though, this is a monad in Haskell. It's something that has these two functions. The function return, which takes a value of A and returns a monad of A. And a function called bind. This is how you write bind in Haskell. The greater than equal is obviously pronounced bind. And it takes a monad of A, it takes a callback function that will get an A and return a monad of B, and it returns a monad of B. This, I assume that you don't all read Haskell, so I've translated this into TypeScript for you. Does that look familiar? So I've changed the return, of course, because return is a reserved keyword in JavaScript. I've changed it to unit, and because you're not allowed to have funny characters in function names, I've had to change the bind to then, arbitrarily. Actually, this is exactly like our async interface, isn't it? Exactly like a promise. So you've actually seen the I/O monad. That's the promise. You've seen the maybe monad. That was my weird little maybe thing, though the maybe monad is slightly more useful. And this is monad comprehension in Haskell. This is monad comprehension in JavaScript, if you can believe it. It's exactly the same principle. Just using that thing shaped like a promise, and we're using the run function and a convenient coroutine to get the same effect. So, mind you, I say that this is all a monad is. Are there any actual Haskell programmers in the audience? A couple of you. I'm sure all of you are just jumping off your seats going, well, actually, there's more to it than just this shape like a promise. You do, of course, have to have the three monad laws, so I'm including them. For completeness, left identity, right identity, associativity. And if these equations don't hold true, it's technically not a monad, but that's not really important. The important bit is that promises are essentially monads. That's how they look. Combine them with your friendly neighborhood coroutine and the run function. You've got monad comprehension. There's nothing more to it. And it allows you to do I/O async code in JavaScript extremely neatly. We've had it all the time. We just didn't talk about the M word. We don't use that word for things like promises. That's really all there is to it. So I'm terribly sorry. I've just taught you monads. That's right at the end, I'd like to actually mention the co-library, which is where this actually gets useful. Because my run function is fairly basic. For one thing I mentioned, it doesn't handle errors. The co-library is a better implementation of the run function that deals with all this stuff. It's freely available on NPM, on GitHub. If you want to try this out in real code, that's the thing that you should be using, not copying my run function. And that's it. Thank you.